Hello friends, today we are going to discuss the question number 2 from the JEE advanced paper, the paper 1 of 2016. In this question, a stick is given. The length of the stick is L and the mass of the stick is M. It is held against a wall, vertical wall, such that the stick makes an angle 30 with the wall, and the wall is smooth, the horizontal surface is rough, and we have to find the value of H by L. This is what we have to find, and also the friction force acting between the lower end of the rod and the rough floor. What else is given? The rod is supported by the wall such that a small portion of the rod is still beyond the wall. So it means a small portion will be the L minus X length. This length is X and this length will be L minus X. The point where the stick is touching the wall is at a distance H from the horizontal surface. So how we can start? Of course, the rod is held at rest, so the net force on the rod must be 0, and it is in translational equilibrium. It is also in rotational equilibrium because the net torque on the rod must be 0. So we can apply the equations, and the unknowns involved will be the forces between the rod and the horizontal floor, and the rod and the vertical wall, the weight of the rod, the friction force between the rod and the horizontal floor. So we'll make equations in some unknowns, and we'll solve the equations, and accordingly after that we will find the ratio H by L and the friction force F. We have to mark the forces. Where are the forces acting on the rod? Clearly the weight mg of the rod will act at its center of mass. So this is the point where mg is acting. The normal force between the rod and the horizontal floor, let this force be N1. The normal force between the rod and the wall as given in the question is perpendicular to the rod. This is according to the question. We are considering it as N2. The friction force acting between the rod and the floor is F. So this is force F. So now we have marked all the forces on the stick. The first thing we have to do is taking the components of force N2 along the wall and perpendicular to the wall. So we have to consider the forces accordingly, the vertical forces and the horizontal forces. So clearly this angle is 30, so this angle will be 30 and this angle is 30. Now what are the forces along vertical and horizontal? Clearly this N2 will be in upward direction, this is N2 sin 30. In the leftward direction this will be N2 cos 30. And at the lowermost point of the rod, the forces are N1 upward and F rightward. So what are the vertical forces now acting on the rod? So suppose I want to draw the force diagram, that is the free body diagram for the rod. So what is the net upward force acting on the rod? Net upward force acting on the rod N2 sin 30, which can be written as N2 by 2 plus N1. What is the net downward force acting on the rod? Net downward force acting on the rod is mg. So for translational equilibrium, we can consider for translational equilibrium, net upward force must be equal to net downward force. So this will be our first equation. One information given in the question is the normal force acting between the rod and the floor and the rod and the vertical wall are equal in magnitude. So I can write N1 is equal to N2. This is our second equation. And one more equation we can find by considering the horizontal forces. What is the horizontal force acting on the rod from the floor? So F is rightward, and from the wall it is N2 cos 30 leftward, which is root 3 by 2 into N2. So I can write net leftward is equal to net rightward. So that is root 3 by 2 N2 is equal to F. This is our third equation. So how many unknowns we are having till now? N1, N2, F. Now we have three equations with three unknowns, N1, N2 and F. By solving these three equations we can find the values of N1, N2 and F. So we have thrice of N1 by 2 is equal to mg. So N1 is equal to 2 mg by 3. The mass of the rod as given in the question is 1.6 kg. So this is 2 into 1.6. The value of acceleration due to gravity is 10 meter per second square. So this is I'm getting as 32 by 3 Newton. So N2 is also the same. So by solving these equations, we have found the values N1 and N2 both are equal to 32 by 3 and F is equal to 16 by root 3 Newton. Now the second part of the question is to find the ratio H by L. For that we need to consider the rotational equilibrium of the rod. So we have to consider the torque of various forces acting on the rod. As you can see, if we consider this point, torque about this point, so the torque of friction force and normal N1 will be 0. So we can have the torque of weight mg and the torque of N2. So we'll consider torque about this point, the point A. Torque of mg about A. So we know that the torque of a force is equal to force into perpendicular distance of the line of action of force from the point. So the perpendicular distance will be L by 2 and the force we have to consider as mg sin 30 because the mg sin 30 is perpendicular to the line joining, the point where the force is acting and the point about which you are going to find the torque. So torque of mg will be mg sin 30 into L by 2. So this will be mg into L by 4. And the torque of this normal N2, torque of N2 is N2 into perpendicular distance from the point. So what is the perpendicular distance? That is x. So I will write x here. Now both of these must be equal and opposite. As you can see, the torque of weight is clockwise and the torque of N2 must be anti-clockwise. So both must be equal and opposite. So I will have to equate these two. mg into L by 4 is equal to N2 into x. 16 into L by 4 is equal to 32 by 3 into x. So L is equal to into x by 3. We have found the relation between L and x, but in the question they have asked the value of h and L. How to find relation between h and x? Clearly h by x is equal to cos 30, so h by x is equal to root 3 by 2, so x is equal to 2 by root 3 into h. So we have L is equal to 8 by 3 into x, which is 2h by root 3. So h by L is equal to 3 root 3 by 16. This is our answer. So we have got the ratio h by L, and also friction is equal to 16 by root 3. So this is our answer D in the question.